So today I want to walk through calculating rate of change or slope. Remember, they're interchangeable, and I want to just walk through three examples. One from ordered pairs, one from a table, and one from a graph. So remember, once, as I said earlier, rate of change and slope mean the same thing. Okay, so let's look at this first one. We are given an ordered pair. This is the ideal example of when we are going to use that slope formula, okay, that m equals y2 minus y1 over x2 minus x1. The first thing that we are going to do is I'm going to label my points. That way I know all I have to do is plug it in. So here, this is my x1 and my y1. Here's my x2 and my y2. And now I'm simply going to plug it into my formula. So here, my first one is I need to fill in my y2. So that is -8 minus, and my y1, okay, is -6. I like to use parentheses because here, notice I got a double negative. I do not want to drop that negative. All over x2, which is 7, minus my x1, which is 1. And now I'm going to simplify. And you can plug this into Desmos exactly as you've written it, and it will simplify it for you. So -8 minus -6. Well, good thing I didn't drop my negatives, because remember, that double negative is going to turn that into a positive. So I'm left with -2. And 7 minus 1 over 6. But we're not done. So with rate of change, we always want to simplify. And -2 over 6 can be simplified to -1 over 3. So my slope, indicated by my variable m, is -1 over 3. Now let's go ahead and look at a table, and we're going to do the table the same way because we have multiple ordered pairs. First thing, we're going to label them. So here is my x1, y1, x2, y2, and you can use any two of these ordered pairs. So if you wanted to use -2 and -6 and -4 and -10, it is still going to work in a linear table. So let's plug this into my slope formula, okay? And as you recall, our slope formula is that my slope, m equals y2 minus y1 over x2 minus x1. And now I'm going to plug it in. So my y2 is here at -8 minus my y1, which is -10. Once again, I'm going to use that parentheses. I do not want to forget or drop that negative. All over my x2, -3, minus my x1, which is -4. Okay. Big thing to remember here is that the subtraction is part of the slope equation. Okay, so don't just think because you have a -10, you don't have to put that subtraction sign in there. And now if I plug this into Desmos, -8 plus 10, that turns it into a +2 over 1. So my slope is 2 over 1, or I can just write this as a slope of 2. And here's our last one. Let's find the slope or rate of change from a graph. Now, you still use the slope formula. You could find two ordered pairs and plug them into the formula. Okay. Another way that you could use your graph is just to find two exact points. Remember, those are going to be points that are exactly on the grid line. So for example, 0, 2, exactly on the grid line, that is an exact point, whereas let's find another color. If I do something in green, this one here, that is not an exact point because I'm guessing what that x and what that y value is. So you want an exact point on the grid line. So I'm going to choose two exact points. I always like to use my intercepts if they're available. They're easy to see. Okay. And then I am going to draw my slope triangle. Okay, I'm going to connect this and draw my slope triangle. And now remember that slope or rate or change is our change of y over our change of x, or delta y over delta x. So now let's count. What did my y do? Well, it went down. It went down 2. And then what did my x do? My x went over 4. Okay. So my rate of change is down 2 over 4, and that can be simplified to 1 over 2. Now, because this went down, this is going to be a negative. Okay. Another way to look at it is look at the direction of my line. Okay, remember we always read a graph from left to right. It is heading down or down the steps. So that's how we know it's a negative slope. How we can check this is if my slope is down 1 and over 2, I should be able just to plot that on my graph. So if I start here at exact point and I go down 1 and over 2, do I hit another point? Yes, down 1 over 2, down 1 over 2. And so I know that my slope is correct.